Hey grade sixes, we're going to be talking about lines and angles. Now our lives are surrounded by line and angle all around us. It's all in nature, it's in architecture, it's in all the buildings around us. But what does it mean? And what are the different types? So we're going to be looking at that today. So the first thing we want to talk about is the different types of line. Now you see three different lines here, but do you know the difference between the three? What would this first one be called? Well, surprise, surprise, it's called a line. And a line, by definition, basically goes for infinity in both directions. And what I tend to think about is a comet, and how a comet's tail, we have no idea where it started or where it ends. It just keeps going on forever and ever in both directions. But if this is the definition of a line, what are these last two? What is this middle one? Well, if you guessed a ray, you are correct. And what a ray does is it starts at a certain point and it goes on forever in another point. Can you think of where we used the term ray before? Well, we use it in regards to the sun. Hey, you catching any rays lately? Yes, it starts at the sun and it basically goes on forever in all directions. So if this is a line, this is a ray, then what is this? It's a line segment. It's as if someone grabbed a part of the line up here and just put a stop on both ends. And that's what a line segment is. And we see that in architecture all around us. Look at the windows and the lines that are in it. They all end and they all go in straight lines. So that is a line segment. Well, if those are lines, then when two rays come together, they can form an angle. And where they come together at the midpoint is called the vertex. That's where they meet at the very bottom. And then to refer to this angle, we could put names on the different points. And let's, for example, refer to this as angle ABC. And we use a symbol here that says the angle. So that refers to angle ABC. But why can't we refer to it as BCA or CAB? Well, I'm sorry, but you can't use that at all. And the reason is the middle letter here is the crucial one. That B is the vertex. So you always have to have in your name of a line, or I'm sorry, in the name of an angle, you have to have the vertex in the middle. So you have the angle sign, then you have ABC. Now if we redid these letters, then it would change the name of it, but always you have to name that vertex in the middle. So now that we're familiar with lines, we're familiar with how they come together to form an angle, let's look at how we would measure those angles. And to do that, we have to use our tool called a protractor. Now a protractor has two different measurements on it. You'll see that on the outside here, this one starts with 0, and the numbers go all the way across the outside to the other side where it ends up at 180. There's a second measurement as well on the inside. Again, it starts over at 0 on this side, and it goes over to 180 on this side. Now the reason that a protractor does that is it depends where the line starts. If the line is on this side, and it's starting on this side, we use the inside because that's where the 0 is. If the line begins on this side of the protractor, that's where the 0 is, and so you use the outside. So let's take a look at a sample angle that we could measure here. So if we've got a measurement, and you'll see that when we're doing a measurement, we have to line it up, line the vertex of the angle, remember where the two rays meet, right in the corner, vertex of the angle with the vertex of the protractor. And this is sort of like the crosshairs if you're playing video games and you're playing those shoot 'em up games or something, then you always have the crosshairs that you have to line things up. It's the same thing with a protractor. So put the vertex of the angle on the vertex of the protractor. The other thing is that the angle baseline has to be right on the 0 line. So make sure that's there, make sure the vertexes are lined up, and then you can just take a measurement. Now notice the line here starts at this 0, so we have to use the inside, so we would say this is 40 degrees. And if we make it bigger, say we make it up to there, then once again we'd start at this 0, we'd look up and we'd say 70 degrees, and then we would look onto the end, so it would be 71. Notice there's a halfway point, a line there that says 75, and then it's 76, 77, and this would be a 78 degree line. So let's try measuring one over two of these angles and see how it works out. So if we take our angle here, and we're going to take our protractor and let's make it a little smaller. And we're going to move the protractor. We have to line up the baseline first of all, and then slide the protractor over so the vertex from the protractor and the vertex from the angle line up, and those are called the vertices when you've got more than one. And then you can see that you start with the 0 at this side and you end up to 40 degrees. So that indeed adds up to 40 degrees. What if we were to make this angle smaller? So let's clone this, and we'll take this second one up here and we'll make it smaller, and we've got this one a little bigger. Now does that change our measurement? Let's move our protractor on to find out. Okay, we line up our baseline, we line up our vertices, and we've got 40 degrees there on the big one. Now we'll do the same with the small one. We line up our baseline, line up our vertices, and it's still 40 degrees. So angle measurement does not change based on the size of the lines. The lines have no difference on it. The angle measurement is just based on the rotation from the baseline to the new line. So it's all based on a rotation, and no matter how big it is, it can still have the same angle. What happens if we have a big angle? And say an angle like this. How are we going to measure that? Well, let's get our protractor a little smaller, and we'll move it up and move this over. So the first thing that we have to do, this angle has basically gone all the way around, and we actually see what the answer is, but let's see how we can measure it with this protractor. So we would grab the protractor and move it onto the baseline. So you'd have to line up our baselines here. So I'm going to line up the vertex first, line up the vertices, and then we'll get our baseline. So there we go. So that is lined up, and there's two ways that we can do this. First of all, you can see that this is measured into, there's 10, we're starting at this 0, there's 10, it's between 10 and 20, so we look at the end and we can see that it's right on the 15, so this is 15 degrees. So if we were to take that 15 degrees and subtract it from 360, we would end up with 345 degrees, and you'll see that that's exactly what the answer is. So it's just a matter of starting at the 0 line, or say the 360 line here, and measuring the difference between that and the blue line, or where the line began. And so that would be 360 minus 15 gives you 345. Another way you can do it is you can take this side of the protractor, and you can see all the way from here to there. Well, you know how far that is. That's 180 degrees. And then what we do is we use our outer scale and we add to that whatever we get to. So we've gone from 0 all the way to 165. So then if you take 180 plus the 165, we end up with 345 as well. So those are two ways that you can figure out an angle that's bigger than your protractor. The other way to do it is called a 360 degree protractor, and all you have to do there is you start at the 0, you can see here, and it goes all the way around, and it's already at 345 degrees. Now some students have access to a 360 degree calculator or a 360 degree protractor, but many of us have to stick with using the 180. So I've given you two methods to do it. You can either subtract from 360 the difference, or you can add 180 plus whatever the additional angle is to get what the difference is. So let's go on to types of angles. But just before that, let's watch a song.
Measure in degrees of every angle that I see. Come on, angles, don't you tangle with me. All you acute angles I see are less than 90 degrees. Come on, angles, don't you tangle with me. And if you measure 90 degrees, then I know you are a right angle, 'cause you stand perpendicular. I got your number. If you were straight, it's 180 degrees that you make. Come on, angles, don't you tangle with me. A full rotation, if you please, spins around 360 degrees. Come on, angles, don't you tangle with me. But if you're only greater than 180 degrees, I know you're a reflex angle, like my bended knees. Come on, angles, don't you tangle with me. Come on, angles, don't you tangle with me. Give me my protractor back, please.
Wow, thank you for that musical interlude. Okay, so to sum up, we're going to be talking about our types of angles. So the first thing is we've got our protractor here, and as you know, we can move this angle to be anything and produce all kinds of different angles. Well, all those angles have different types of names. So we'll start with the smallest angle. This angle you can see is 40 degrees, but these little tiny angles, they're so little cute. We call them an acute angle. And yes, if they're an acute angle, how could you think of anything but a little puppy? So that is a cute little angle. So when you think of anything under 90 degrees, think of that cute little angle. Now on the other hand, you've got this one, which is at right angles. And when we think of a right angle, we're thinking of something that is perpendicular to each other. So it goes perpendicular. So here is a right angle, and that's set up that way. Now this big boy, he's obese. He is obtuse. And when I think of a big obtuse angle, I think of someone who is obese. Yes, obtuse, obese, it's a big, big angle. Anything over 90 degrees and under 180 is obese, obtuse, obtuse. Then you've got your straight angle. And the straight angle is just as it sounds like, just straight as an arrow. And you've got all kinds of examples of that as well. Now what happens if the angle goes way around 180? Well, what I think of there is I think of our knee examinations that you sometimes see on TV, and that is reflex. Because what happens is our angle of our knee goes from, say, here all the way around to there, which is more than 180 degrees, and so that is called a reflex angle. And if you think of what the doctors do on TV with testing your reflexes, then that will help you think of reflex. And the last one is a circle. And the circle basically goes all the way around. It's a 360-degree angle. So there's an introduction to lines and angles. Hope you pick something out. Enjoy.